The pyramids stand silent beneath a blanket of stars. What if the Egyptians saw these lights not as distant gods, but as a cosmic blueprint for their entire world? We are going beyond the myths to uncover a sophisticated science, a system of astronomy so advanced it engineered their calendar, directed their construction, and dictated the rhythm of daily life. By the end of this journey, you will see the night sky through the eyes of a civilization that used it as a tool. We will explore why a pyramid's shaft points to a single star and how a temple's alignment could capture the sun. What part of our modern world might still be guided by their ancient observations? We often picture the ancient Egyptians on their knees, praying to a sky filled with divine beings. It is true their world was woven with myth. The sun was the god Ra sailing his bark across the heavens, and the stars were the souls of the blessed dead. But to see only gods in their sky is to miss half the picture. Look closer, and a different system emerges, one of breathtaking precision. The Egyptians were master observers. They saw the same stars not as capricious deities, but as fixed points of light that returned to the same position at the same time every year. They watched the planets, which they called the ones who know no rest, and meticulously recorded their strange, wandering paths against the backdrop of constellations. This was not just mythology, it was a science. This is the crucial divide between mythological astronomy, which gave the cosmos a story, and practical astronomy, which used the cosmos as a tool. The stories of the gods are well known, but the incredible scientific achievements, the engineering of time and space itself using the heavens, that is a story less often told. It is a story written not in papyrus, but in the very alignment of their greatest monuments, a story we are only just beginning to decode. In a dark chapel of the Hathor Temple at Dendera, a stone ceiling holds a secret that stunned the first Europeans who saw it. When French explorers cleared the sand and soot in the late 18th century, they uncovered an enormous circular map carved in stone, a breathtakingly detailed depiction of the night sky. This was the Dendera Zodiac, and its discovery sent shockwaves through the scholarly world. Here was proof that the ancient Egyptians possessed a sophisticated understanding of the cosmos that went far beyond simple stargazing. The zodiac is a beautiful and complex puzzle. You can clearly see familiar figures like Leo the lion and Taurus the bull, constellations we still use today. But look closer, and you will find Egyptian gods and symbols woven into the same celestial tapestry. A ram is not just Aries, it is the god Amun-Ra. A bull is not just Taurus, it is the sacred Epes bull. This is not a purely Egyptian sky map, nor is it a purely Greek one. It is a fusion, a product of a time when Egypt was under Greco-Roman influence, blending two great astronomical traditions into a single, magnificent artifact. This fusion is the very source of a heated debate that continues to this day. What was its true purpose? Was it a grand star map for priests to read the heavens, a religious calendar marking the festivals of the gods, or something even more advanced? Some researchers argue the arrangement of figures and symbols could be used to track the movements of planets and predict eclipses, making it a powerful computational tool. The Dendera Zodiac refuses to give up a single, simple answer. It stands as a silent witness to a culture that saw no contradiction between the divine and the scientific, where a constellation could be both a mythical beast and a precise marker of time. But this stone map was not the only way the Egyptians pinned the sky to the earth. Their ambition stretched much, much further. That same obsession with mapping the heavens found its most practical application not on a temple ceiling, but within the confines of a coffin. Deep inside the tombs of nobles and pharaohs, painted onto the very lids that sealed them for eternity, are intricate diagrams of the night sky. These are the star clocks, a system of timekeeping so elegant it divided the darkness with scientific precision. The system was built around 36 star groups known as decans. Each decan was a small constellation or a single bright star, and they rose in a precise, unchanging sequence. Think of them as 36 markers, placed at regular intervals along the sun's path through the sky. The key to the entire system was a specific moment, the instant just before dawn. On any given night of the year, one of these 36 decan stars would make its first appearance, its heliacal rising, in the eastern sky moments before the sun washed out the lesser stars. That star marked the last hour of the night. The appearance of the next decan in the sequence would mark the next night's final hour, and so on in a grand, slow-moving cycle. This created a celestial calendar that marched in perfect step with the solar year. But the Egyptians took this further, using the decans to tell time throughout a single night. The diagonal star clocks painted on coffin lids are essentially star tables. They chart which decans are visible in the sky during each of the 12 hours of the night for every 10-day period of the year. A priest or timekeeper would simply identify the current date, observe which decan was crossing the meridian, an imaginary north-south line across the sky, and read the corresponding hour from the table. This was a 24-hour clock written in the stars, operating with a reliability that no water clock or sundown could match in the depth of night. It was a system born from a need to structure time for religious rituals, for night watches, and for the simple human desire to measure the passage of the unseen. The silent, predictable dance of the decans gave order to the chaos of darkness, proving once again that for the Egyptians, the sky was not a mystery to be feared, but a magnificent, ticking machine to be understood. This same celestial clockwork was carved into the very bedrock of Egypt. Far above the painted coffin lids, the Great Pyramid of Giza stands as a monument to this astronomical precision. Its four sides are aligned to the four cardinal directions, with an accuracy that seems impossible for a structure built over 4,000 years ago. The north-south axis is nearly perfect, deviating from true north by only a fraction of a single degree. So how did an ancient civilization achieve such an exact alignment without modern tools like magnetic compasses? The answer, it seems, was written in the stars. One compelling theory points to the circumpolar stars, the ones that never set below the horizon as seen from Egypt. They endlessly circle the north celestial pole. Ancient builders could have used a simple plumb line, a weighted string, to track the path of two specific stars, Kochab in the Little Dipper and Mizar in the Big Dipper. Imagine an Egyptian astronomer on a clear, dark night. He would mark the spot on the ground where his plumb line falls when aligned with one star at its highest point in its circle. Then he would wait patiently until the second star reached its own highest point and mark that spot as well. A line drawn perfectly between these two marks would point directly to true north. This method transforms the entire sky into a giant, rotating compass. The slow, predictable dance of these eternal stars provided a fixed reference point in a turning universe. This was not magic. It was meticulous, repeated observation, a practical application of a deep understanding of celestial mechanics. The pyramid's perfect orientation is therefore a silent testament to a science that used the heavens as its ultimate blueprint. This celestial blueprint was not just a matter of direction, but perhaps of grand imitation. High above the sands of Giza, three brilliant stars form the unmistakable line of Orion's belt. For centuries, their arrangement was seen as just another constellation, but a radical theory suggests this was not a coincidence. The Orion correlation theory proposes that the three great pyramids at Giza are a perfect, intentional mirror of those three stars. The evidence for this idea is both visually compelling and deeply controversial. Researchers like Robert Bovell pointed out that the layout of the two larger pyramids, Khufu and Khafre, along with the slightly offset smaller pyramid of Menkaure, matches the pattern of the belt stars Al-Nitak, Al-Nilam, and Mintake with startling accuracy. The theory argues that the so-called misalignment of Menkaure's pyramid is not a mistake at all, but a deliberate recreation of the third star's position in the sky. Proponents also highlight the way the pyramids are positioned in relation to the Nile, suggesting it was meant to represent the Milky Way, creating a vast, terrestrial map of the cosmos on the ground. This was not just an artistic tribute, but a sacred act of joining the earth with the heavens, a belief core to the pharaoh's journey after death. Yet, this grand interpretation is met with strong skepticism from mainstream Egyptology. Critics argue that while the visual match is intriguing, the archaeological and textual evidence is simply not there. They point out that no ancient Egyptian text ever mentions such a correlation. The perceived offset of the third pyramid, they suggest, can be explained by practical constraints of the bedrock geology or the evolving architectural plan, not by celestial mimicry. Furthermore, precise astronomical calculations show that the alignment was a closer match to the stars as they appeared around 10,500 BCE, a date far earlier than the accepted construction timeline of the pyramids. This creates a massive chronological problem that the theory struggles to resolve. So we are left with a beautiful, haunting possibility, a pattern written in stone and stars that feels too perfect to ignore. Yet the hard evidence remains just out of reach. Whether a deliberate map of the afterlife or an incredible coincidence, the theory forces us to look at these monuments not as isolated tombs, but as pieces of a much larger, cosmic puzzle. And if the pyramids were a mirror for the stars, what other structures might have been designed to capture the light of a single, life-giving god? While the pyramids may have mirrored the belt of Orion, another monument seems to gaze directly at the lion in the sky. The Great Sphinx, with its lion's body and human head, has always presented a riddle. But what if its greatest secret is not its missing nose, but its true age? A controversial theory suggests this iconic statue is not 4,500 years old, but rather a staggering 12,500 years old, a relic from a forgotten age. This idea hinges on a celestial alignment. The theory proposes that around 10,500 BCE, the constellation Leo would have risen directly in the eastern sky, perfectly aligned with the Sphinx's gaze during the vernal equinox. This was the dawn of the age of Leo, a 2,000-year period defined by the sun's position in that constellation at the spring equinox. The Sphinx, as a lion, would have been a perfect terrestrial marker for this celestial event, a monumental sentinel greeting its cosmic counterpart. The evidence for this is not just in the stars, but in the stone itself. Geologists point to the deep, vertical fissures and undulating erosion patterns on the Sphinx's body and its enclosure walls. This type of weathering, they argue, is characteristic of heavy, prolonged rainfall. Egypt's climate was significantly wetter many thousands of years earlier, but has been predominantly arid for the last 5 millennia. The erosion we see, according to this view, could not have been caused by wind and sand alone, but required centuries of torrential rain, pushing its construction date back to a much more ancient, pluvial period. This theory is supported by the astronomical phenomenon known as precession. The Earth wobbles on its axis over a cycle of about 26,000 years, causing the position of the constellations at the equinoxes to slowly shift backward through the zodiac. Calculating this precessional cycle backwards places Leo on the horizon at the vernal equinox, right around that remote date of 10,500 BCE. The alignment, the geology, and the astronomy seem to weave a compelling story. Yet, the mainstream academic community remains deeply skeptical. Egyptologists counter that the archaeological context is clear. The Sphinx is part of the funerary complex of the pharaoh Khafre, and its head is a likeness of that king. They offer alternative explanations for the erosion, suggesting it could be the result of groundwater seepage or the effects of wind and salt crystallization exfoliating the soft limestone. They also point out that there is a complete absence of any cultural artifacts or evidence from that proposed earlier time period at the Giza Plateau. If the Sphinx is that old, who built it, and why is there no other trace of their civilization? So we are left with a profound standoff. On one side, a captivating alignment of geology and astronomy that points to a lost epoch. On the other, a consistent archaeological record that places the statue firmly within the timeline of the Old Kingdom. This is not a question with a simple answer, but a true mystery carved in stone, its silent gaze challenging us to reconsider everything we think we know about the dawn of civilization. While the Sphinx may have faced the stars, the true master of the Egyptian sky was the sun. Its daily journey was the heartbeat of their world, and they engineered colossal structures to measure its every move. Towering obelisks, those slender, needle-like monuments, were far more than just religious symbols. They were the hands of a giant sundial, casting a precise, moving shadow across the land. At their base, the ground was often marked with lines indicating the hours. As the sun traveled from east to west, the shadow would sweep across these markers, dividing the day into measurable segments. But these stone giants did more than just tell time. The length and direction of their shadow changed with the seasons. The longest shadow of the year marked the winter solstice, the shortest the summer solstice. In this way, a single obelisk served as both a clock and a calendar, its silent, dark finger tracing the sun's eternal cycle for all to see. This solar precision reached its most spectacular expression deep within a mountain. At the Temple of Abu Simbel, Ramses II engineered a miracle of light. The temple was carved so that its inner sanctum, housing statues of himself and three major gods, lay in total darkness for most of the year. But on two specific days, around October 20th and February 20th, the rising sun would pierce the entire length of the temple corridor. A shaft of light would illuminate the statues of Ra, the sun god, and Ramses himself, while leaving the god of the underworld, Ptah, in perpetual shadow. This was not a happy accident. It was a calculated demonstration of the pharaoh's divine connection to the solar cycle, a connection built on generations of exact observation. The Egyptians' reverence for Ra was inseparable from their science. They knew the sun's path was not random. They tracked its shifting position on the horizon at sunrise and sunset, understanding that this cycle of moving north and south governed the flooding of the Nile and the rhythm of planting and harvest. Their worship was an act of timing, their prayers synchronized with a celestial body they had learned to predict with stunning accuracy. They built a civilization in perfect harmony with the sun's reliable dance, proving that their greatest power was not just in praising the light, but in learning to read it. But of all the stars they watched, one held a power over their lives like no other. This was Sopdet, the stellar goddess we know as Sirius, the dog star. For the ancient Egyptians, Sopdet was not merely a point of light, it was a divine herald of life itself. Its annual reappearance was the most anticipated event of the year, an event that dictated the rhythm of their entire civilization. After a period of roughly 70 days when Sirius was invisible, lost in the glare of the sun, it would make its dramatic return. Just before dawn, in the middle of July, a solitary, brilliant spark would pierce the twilight low in the eastern sky. This moment, the star's first glimpse after its long absence, is called the Heliacal Rising. For the Egyptians, this was the start of a new year, the opening of a grand, celestial ceremony. The rising of Sopdet was a promise. It signaled that the Nile's life-giving flood was imminent. Within a matter of weeks, the river would burst its banks, spreading a layer of rich, black silt across the farmlands. This was not just a seasonal change, it was the foundation of their survival. Without this annual inundation, the soil would be barren and famine would follow. The entire agricultural cycle, from planting to harvest, was set in motion by this single astronomical event. This created a direct, undeniable link between the cosmos and the Earth. The priests who tracked Sopdet's movements were not just stargazers, they were the nation's master planners. By predicting the flood, they enabled the pharaoh's government to organize the entire population, to store grain, and to prepare the fields. The star's appearance was so reliable that it formed the basis of their civil calendar, a year of 365 days divided into 3 seasons: inundation, emergence, and harvest. This was one of the first solar calendars in history, and it was born from the precise observation of a single star's relationship with the sun. So when you look up at Sirius tonight, remember that you are seeing more than just the brightest star in our sky. You are witnessing the same celestial clock that once told an entire civilization when to sow, when to reap, and when to celebrate the rebirth of their world. This mastery of the stars and the sun culminated in one of history's most brilliant administrative tools, the Egyptian calendar. Far from a single system, they engineered a complex, dual-track method of tracking time that balanced the demands of the Earth with the rhythms of the heavens. On one hand, they developed a civil calendar of 365 days, divided neatly into 12 months of 30 days each, with 5 extra days added at the year's end. This was a purely solar calendar, one of the very first of its kind, and it was the engine of their state. It governed taxation, record-keeping, and the scheduling of the vast agricultural workforce. Its predictable, unchanging length made it a pillar of bureaucratic order. Yet for their religious life and sacred festivals, they relied on an entirely different system, a lunar calendar. This calendar was based on the cycles of the moon, with months that began with the first crescent and lasted roughly 29 or 30 days. This created a shorter year, meaning lunar festivals would slowly drift through the solar seasons. A festival held in the summer one year might, over a decade, occur in the spring. This duality reveals a sophisticated mindset. They used the sun's unwavering cycle to manage their kingdom, while honoring the moon's changing face to connect with their gods. But this created a fascinating problem. Their 365-day civil year was actually about 1/4 of a day shorter than the true solar year. This tiny, almost imperceptible difference added up. Each year, their civil new year slipped backward by roughly 1 day against the actual seasons. This meant the heliacal rising of Sirius, the event that was supposed to mark the start of the inundation and their new year, would gradually occur on a different civil calendar date. Imagine watching your official calendar slowly fall out of sync with the world around you. The flood would arrive, but your calendar would say it was the wrong day. The solution to this drift was not a correction, but an acceptance of a grand, cosmic cycle. The Egyptians understood that it would take 1,460 of their civil years for the calendar to realign perfectly with the stellar year of Sirius. This immense period is known as the Sothic cycle. The very fact that their texts and priests were aware of this cycle demonstrates a breathtaking long-term astronomical vision. They were not just planning for the next harvest, they were thinking in units of time that spanned over a millennium. Their calendar was not a perfect, locked clock, but a living system that acknowledged its own subtle dance with the cosmos, a testament to a civilization that watched the sky not for days, but for ages. North of the Grand Plateau at Giza, on the high desert of Abu Rawash, stands a pyramid that tells a different story. The Pyramid of Djeddafar, son of Khufu, is a ruin, its core stones largely dismantled, giving it the appearance of an unfinished project. Yet its location is a powerful statement. Perched on a hill higher than any other pyramid site, it commands a panoramic view of the sky, a fact that has led some researchers to wonder if its ruinous state and elevated position are clues to a deeper, astronomical purpose. While the mainstream view holds that the pyramid was simply abandoned and later quarried for stone, an alternative theory suggests its construction was always meant to be different. The pyramid's subterranean structures are complex and complete, including a deep, narrow burial pit. This has fueled speculation that the above-ground structure was never intended to be a perfect, smooth-sided pyramid like those at Giza. Perhaps it was designed as a different kind of monument altogether, one where the open, unfinished summit served as a perfect, stable platform for observing the heavens. From this unparalleled vantage point, an astronomer priest would have had an unobstructed view of the northern circumpolar stars, the very stars used to align the Great Pyramids, as well as the entire eastern horizon. This makes the star Sirius a prime candidate for investigation. The heliacal rising of Sirius was the most critical celestial event of the Egyptian year, heralding the Nile flood. To observe this first, faint glimmer of Sopdet just before dawn, you would need a clear, high horizon. The Abu Rawash site provides exactly that. Could the unfinished pyramid have been an enormous, fixed observatory, its very structure facilitating the precise timing of this life-giving event? The evidence remains circumstantial, a compelling puzzle of location and possibility. There are no surviving texts that spell out this purpose, yet the site continues to challenge our assumptions, forcing us to ask if a pyramid's true function was not just to house a body for eternity, but to provide a perfect window to the cosmos. Deep within the bedrock of the Valley of the Kings, far from the light of the sun, the ceilings of royal tombs unfold into a breathtaking replica of the night sky. In the tomb of Ramesses VI, known as KV9, you do not look up at a flat stone roof, but into a vast, painted cosmos. The ceiling is a deep, mesmerizing blue, a canvas for a meticulously drawn chart of the heavens. Constellations we still recognize are here, alongside mythical Egyptian figures and hieroglyphic labels for the decans stars. This was far more than decoration. It was a functional, celestial map designed to guide a king on his most perilous journey. The central theme of this and other tombs, like the magnificent KV-17 of Seti I, is the sun god's nightly passage. The Egyptians believed that after Ra set in the west, he did not simply vanish. He traveled through the 12 perilous hours of the night within the body of the sky goddess, Nut, who is often depicted stretching across the entire ceiling, swallowing the sun at dusk to give birth to it again at dawn. Each of these 12 hours was a separate region of the underworld, a cavern or river with its own dangers and deities. The detailed scenes on the ceiling act as a divine guidebook, illustrating exactly what the pharaoh's soul would encounter in each hour. He would need to know the names of the hostile gatekeepers and the correct spells to utter to pass safely. This was a soul navigating by the stars, using the same decans that told time for the living as fixed markers in the darkness of the afterlife. The solar bark, the boat of Ra, is shown in these scenes, carrying the sun god and his crew of lesser deities through this treacherous landscape. They face the serpent Apophis, the embodiment of chaos, who tries to stop the sun's rebirth every single night. The pharaoh's spirit was believed to join this crew, to assist in this cosmic battle and ensure the sun's victorious return, which in turn guaranteed the continuation of life for all of Egypt. This intricate fusion of art, religion, and science reveals a profound truth. The star charts on these ceilings were not random patterns. They were based on generations of precise observation. The decans are in their correct positions. The constellations are accurately rendered. The journey was a myth, but the map was real. The Egyptians used their hard-won astronomical knowledge to build a bridge between this world and the next, proving that their understanding of the cosmos was the ultimate key to immortality. From the painted cosmos of a king's tomb to the hands of a working astronomer, the principles of Egyptian astronomy found their ultimate expression in a tool of beautiful simplicity. This was the Merkit, an instrument so unassuming you might overlook it, yet it held the power to measure the heavens and orient the earth. At its core, the Merkit was little more than a split palm rib, forming a narrow sighting notch and a separate plumb bob, a weighted string that always pointed straight down. With these two simple components, an Egyptian astronomer could achieve feats of precision that would define their civilization for millennia. Its primary use was as a stellar clock for the night. An observer would set up two Merkits, aligning their sights with a specific circumpolar star, one that never set, like those in the constellation we call the Big Dipper. As the Earth turned, the star would appear to slowly sweep a perfect circle around the North Pole. The astronomer would sit facing north, with an assistant positioned a short distance away. They would watch as the chosen star transited, or crossed, a series of imaginary meridian lines. When the star reached a predetermined position in its circuit, aligned perfectly with the two Merkit sights, the observer would call out. His assistant would then note the time by checking a water clock, or by observing which decan star was rising in the east. By tracking several of these transits through the night, they could divide the darkness into precise, equal hours. This was timekeeping stripped to its essence, using the relentless spin of the cosmos itself as the mechanism, but the Merkit's genius did not end with the night. It was also the key to the most breathtaking architectural alignments in history. To find true north for a project like the Great Pyramid, two astronomers would work on a clear, windless evening. They would each set up their Merkit, carefully leveling the base. One would track the highest point, the culmination, of a specific circumpolar star, marking the spot on the ground where his plumb line fell when the star was perfectly centered in his sight. The other would do the same for a different star at its highest point. A line drawn between these two marks would point directly to the celestial pole, and by extension, true geographic north. This method transformed the entire turning sky into a giant, infallible compass. The slight wobble in the plumb line, the exact moment of a star's transit, all required immense patience and skill. This was not a task for an amateur, it was the work of a master. A scientist who understood the predictable patterns of the stars so completely he could use them to anchor a million-ton monument to the axis of the world. The Merkit proves that the Egyptians' greatest astronomical achievements were not just in their grand theories, but in their quiet, meticulous application of cosmic law, using a slit in a palm rib to listen to the rhythm of the universe. This cosmic clockwork, so precise in its movements, was also believed to whisper secrets about the future. Tucked away in temple archives and written on papyrus, the Egyptians maintained detailed almanacs known as the calendars of lucky and unlucky days. These were far more than simple lists. They were a complex fusion of astronomical observation, deep mythology, and everyday superstition. Each day of the year was assigned a prophecy, a forecast of good or ill fortune based on legendary events believed to have occurred on that date in the mythical past. A day might be declared wholly favorable because it was the birthday of a benevolent god, or partially unlucky because it marked a battle in the eternal war between order and chaos. The outcome of a business deal, the health of a newborn, even the mood of the pharaoh could all be influenced by the inherent character of the day itself. But how did they determine which day was which? This is where the stars re-enter the story. The positions and cycles of the decanal stars, the same 36 star groups used for telling time at night, were carefully noted as celestial omens. The heliacal rising of a particular decan could mark the start of a period of misfortune, while the culmination of another might herald a stretch of excellent luck. The movement of planets, the phase of the moon, even unusual celestial events like comets were all woven into this intricate tapestry of divination. A priest astronomer would consult these tables to advise the court on the most auspicious day to launch a military campaign, to hold a coronation, or to begin building a new temple. This system reveals a worldview where no line was drawn between the scientific and the supernatural. The same star whose predictable return allowed them to engineer a perfect calendar was also seen as a divine messenger whose appearance could bless or curse human affairs. The decans were both precise timekeeping markers and powerful spirits. The sky was a text, and every flicker of light held a double meaning, a measurable position and a potent prophecy. Here, the cold mechanics of the cosmos were intimately tied to the warm, messy concerns of daily life, proving that for the ancient Egyptians, understanding the heavens was not just about predicting the flood, but about navigating the equally unpredictable currents of fate. Deep within the Great Pyramid, two sets of narrow shafts angle upward from the burial chambers into the heart of the monument. These are not grand corridors for the living, but mysterious tunnels barely wide enough for a small robot to traverse. For over a century, their purpose has been one of Egyptology's most tantalizing puzzles. Were they simple air vents for the builders, or did they serve a far more profound, celestial function? Modern technology has allowed us to explore these shafts without damaging the ancient stone, sending robotic cameras on a slow journey into the dark. What they revealed was astonishing. The southern shaft from the king's chamber points directly toward the belt of the constellation Orion. The northern shaft aims precisely at Thuban, a star in the constellation Draco that was the pole star when the pyramid was built. This is not a vague alignment. The engineering is exact, suggesting these shafts were deliberate sight lines to specific points in the ancient sky. So we are faced with a compelling debate. The practical explanation is ventilation. These shafts could have provided crucial airflow to the workers deep inside the massive structure, allowing them to breathe during the final stages of construction. Yet, this simple answer feels incomplete. Why would ventilation shafts be so meticulously angled toward stars of immense religious importance? This is where the symbolic theory takes flight. In Egyptian belief, the pharaoh's soul did not die with his body. It embarked on a journey to join the gods in the eternal sky. Orion was seen as the celestial form of Osiris, the god of the afterlife and resurrection. Thuban, as the unmoving North Star, represented the eternal, unchanging axis of the universe. The shafts, therefore, could have been spiritual conduits, physical pathways designed to direct the king's soul straight to its divine destination. One shaft for the soul to travel south to Osiris, and another for it to ascend to the imperishable circumpolar stars. Perhaps the truth lies in a beautiful synthesis of both ideas. The shafts served a dual purpose, a masterful blend of earthly engineering and cosmic faith. They provided the breath of life for the workers who built the tomb, and then became the breath of the soul for the king who lay within it, a final, silent connection between the dark, still chamber and the brilliant, everlasting stars. But the star clocks painted on coffin lids were only the beginning of this celestial science. As we move into the Middle Kingdom, we witness a remarkable evolution, a refinement of timekeeping that speaks volumes about their relentless pursuit of precision. The diagonal star clocks of the Old Kingdom were elegant, but they had a limitation. They were essentially fixed tables, a snapshot of the sky for a specific 10-day period. If you wanted to know the time on a different date, you needed a different table. This system worked, but it was not perfectly fluid. Then came the innovation of the Middle Kingdom. Astronomers began to develop more flexible tables, often inscribed on the inside lids of wooden coffins. These new clocks expanded the decanal system, sometimes listing more than the traditional 36 stars. They also refined the method of observation, focusing more precisely on the meridian transits of these stars. Imagine an astronomer in the dead of night, his Merkit aligned, watching for the exact moment a specific decan star crossed that imaginary north-south line directly overhead. This moment was a clean, unambiguous data point, far easier to measure accurately than a star's first pre-dawn glimmer on a hazy horizon. This shift from horizon observations to meridian transits was a leap forward in accuracy. It was like switching from judging the time by the sun's general position in the sky to using a modern stopwatch. The star's passage across the meridian was a crisp, definitive event. This allowed for a more granular and reliable division of the night hours. The very fact that they identified this more precise method and adapted their entire system around it shows a culture not content with tradition, but actively engaged in improving its scientific tools. This was not a static knowledge passed down unchanged. It was a living discipline, constantly being honed and perfected. The journey of these clocks did not end there. By the time of the New Kingdom and the Ramesside period, this celestial science had ascended from the coffin to the cosmos itself. The star clocks moved from portable wooden lids to the vast, painted ceilings of royal tombs. These ceiling clocks were far more elaborate and beautiful, often integrated into complex scenes of the goddess nut and the journey of the sun, but their beauty was matched by their functionality. The Ramesside star clocks represented the ultimate expression of this timekeeping method. They often charted the continuous movement of decans throughout the night for every single day of the year, a comprehensive almanac written in starlight on stone. The system became more nuanced, accounting for the slight variations in the length of the night throughout the year, a complexity the older diagonal clocks could not easily handle. This evolution from a simple coffin table to a comprehensive celestial map on a tomb ceiling tells a powerful story. It reveals a civilization whose astronomical knowledge was not a single, brilliant flash, but a slow, steady burn that grew brighter over centuries. Each generation of priests and observers built upon the work of the last, refining their methods, expanding their star catalogs, and pushing the boundaries of what was possible with the naked eye and a simple sighting tool. They were not just watching the stars, they were in a constant, silent dialogue with them, learning their language with ever greater fluency, and inscribing that hard-won knowledge into the very walls of eternity. Yet even the decans, with their perfect, predictable rhythm, were not the only players in this celestial drama. Across that starry backdrop moved the Wanderers, 5 brilliant points of light that refused to follow the rules. The Egyptians called them the ones that know no rest, a name that captures their strange, meandering paths with poetic accuracy. These were the planets we know as Mercury, Venus, Mars, Jupiter, and Saturn. Unlike the fixed stars, which rotated in a locked, dependable dance, these lights would slow down, speed up, and even reverse course in puzzling loops against the constellations. This erratic behavior did not confuse the Egyptians, however. Instead, they wove it directly into their understanding of the divine. Each wandering star was seen as a physical manifestation of a major god, its movements reflecting the will and activity of that deity in the realm of the cosmos. The red planet Mars was Horus the Red, a powerful and potentially aggressive warrior god. Jupiter, the largest and often brightest of these wanderers, was linked to the king of the gods himself, Ammon, or sometimes to the falcon-headed Horus who rules the two lands. Venus, that dazzling morning and evening star, was associated with Osiris, the god of rebirth, its cyclical disappearance and reappearance mirroring his own myth of death and resurrection. Tracking these celestial gods was a sacred duty. Priests meticulously recorded their positions, noting when one would pass close to a bright star or when it would begin its retrograde loop. These events were not mere astronomical curiosities. They were divine messages. The movements of Horus the Red, Mars, across the sky could be interpreted as an omen for the success of a military campaign. The close conjunction of two planetary gods might signal a time of great fortune or impending turmoil. This knowledge was then used to time critical rituals and festivals. A ceremony dedicated to Osiris might be scheduled to coincide with the heliacal rising of Venus, harnessing the star's symbolic power of renewal. The very fabric of their cosmogony, their story of how the world came to be, was mapped onto this observed reality. The predictable decans represented the enduring order of the universe, Mot, while the restless planets embodied the active, sometimes chaotic, interplay of the gods that kept that order in a dynamic, living balance. In the eyes of the Egyptian astronomer, the sky was not a static painting, but a vibrant, breathing narrative, where the restless journeys of the gods were written in light for those who knew how to read them. The grandest procession of the ancient world began not with a trumpet's blast, but with a star's first light. For weeks, the priests of Thebes watched the eastern horizon before dawn, waiting for the moment Sopdet, our Sirius, broke free from the sun's glare. Its reappearance was their signal. The Nile's flood was coming, and with it, the festival of Apet could begin. This was no random celebration. It was a meticulously choreographed event where astronomy set the stage for a divine reunion, a journey that would renew the very soul of Egypt. For nearly a month each year, the normally secluded statues of the great triad of gods, Ammon, his consort Mut, and their son Khonsu, were brought out from the shadowy depths of Karnak Temple. They were placed upon magnificent ceremonial barks, glittering with gold and precious stones, and carried by teams of priests on a 2-mile journey south to the Temple of Luxor. The entire city lined the processional route, cheering, dancing, and offering prayers as the gods passed by. But why this specific time? The festival's timing was a masterful blend of 2 celestial cycles. Its start was tied to the second month of the inundation, the season ushered in by the heliacal rising of Sirius. More precisely, it began on the second new moon after that stellar event. This meant the festival of Apet was governed by both the solar year, via Sirius, and the lunar month. The moon's phase ensured the nights during the festival's climax would be dark, a canvas for the stars, while the link to Sirius connected the entire event to the life-giving flood. This was celestial scheduling on a grand scale. The journey of the gods from Karnak to Luxor was a symbolic reenactment of the pharaoh's divine conception and coronation, a ritual that revitalized his royal power and, by extension, the fertility of the land. As the statues traveled by river and land, they were mirroring the journey of the Nile's rising waters, bringing divine energy and literal sustenance to the people. The priests, by reading the stars and the moon, were not just timekeepers. They were the directors of a national drama, ensuring that this vital renewal of king and country happened in perfect harmony with the cosmos. The festival was a living proof that in ancient Egypt, society, religion, and the cycles of the heavens were all threads in the same unbreakable tapestry. While the grand temples and tombs reveal a sky woven with myth, a set of humble papyri unveil the cold, hard math behind the magic. Discovered not in royal libraries, but in the archives of temple scribes, the Demotic astronomical papyri date from a time when Egypt was a crossroads of the ancient world. Written in Demotic script, the everyday language of the people, these texts are not filled with stories of gods and goddesses. Instead, they are packed with columns of numbers, complex tables, and precise instructions. They represent a seismic shift in Egyptian astronomy, moving from celestial observation for ritual timing to a true science of prediction. These papyri contain incredibly accurate tables for forecasting lunar phases, detailing exactly when the moon would be full or new for years in advance. They track the complex movements of the planets, predicting when Mars would appear to reverse its course or when Venus would blaze as the morning star. Most impressively, they include methods for anticipating eclipses, those terrifying moments when the sun or moon seem to be swallowed by darkness. This new predictive power was not born in isolation. The tables show a clear fusion of knowledge, incorporating advanced mathematical techniques borrowed from Babylonian astronomers, who had perfected the art of cyclical prediction, and influenced by the growing Greek tradition of geometric models. An Egyptian priest using these papyri was no longer just a watcher of the sky. He was a calculator of its future. He could tell you not just what was happening in the heavens tonight, but what would happen there a year from now. This was astronomy transforming from a sacred calendar into a computational science, a quiet revolution on papyrus that gave Egypt the power to foresee the very moments the gods appeared to falter. Even with their power to predict the planets, a single celestial event could shatter the ordered cosmos. A solar eclipse plunged the world into an unnatural midday darkness, while a lunar eclipse turned the moon a sinister, bloody red. For the Egyptians, these were not predictable astronomical events. They were moments of pure terror, a direct assault on the very heart of their universe. The culprit was the great serpent Apep, the embodiment of chaos, darkness, and evil. Their texts describe Apep as a colossal snake lurking in the depths of the underworld, waiting for his chance to strike. During an eclipse, he was believed to have successfully attacked the solar bark, swallowing the sun god Ra whole. The temporary blackening of the sun or moon was visual proof that chaos was winning, that the cosmic balance of Ma'at was under direct threat. This interpretation set them apart from contemporaries like the Babylonians, who meticulously charted the Saros cycle to forecast eclipses with mathematical certainty. The Egyptian approach was rooted in a different worldview. They saw the universe as a perpetual struggle between order and chaos, and an eclipse was the ultimate expression of that battle. We have records of these terrifying events. A papyrus from the reign of Ramesses VI describes a lunar eclipse, noting the god has turned his face away, and the land is in darkness. Another text laments the sun's disk being covered in the daytime, the sky becoming still without anyone knowing the hour. These were not clinical observations. They were cries of fear, documenting the moment the world's reliable rhythm stopped. In response, the priesthood sprang into action with rituals of defense and renewal. They did not try to calculate the next eclipse, they fought the current one. Priests in Pharaoh would perform the rite of repulsing Apep, a ceremony involving the burning of wax models of the serpent, the recitation of powerful spells from the Book of Overthrowing Apep, and the shaking of reed spears at the sky. The people would join in, making as much noise as possible by shouting, banging drums, and clashing pots together to frighten the serpent and help Ra's divine defenders subdue him. This collective effort was meant to strengthen the sun god, to force Apep to disgorge the sun and restore the light. It was a cosmic rescue mission, a desperate attempt to reboot the natural order through faith and ritual. This reveals the ultimate limit of Egyptian predictive astronomy. They could track the steady cycles of stars and planets, but an eclipse was different. It was an unpredictable breach in the cosmic order, a moment when their scientific understanding reached its edge and their mythological world, you took full command. In the face of that terrifying darkness, their response was not to compute, but to combat, proving that for all their celestial genius, some shadows required a different kind of power to dispel. The terror of an eclipse revealed the limits of their predictive power, but in the quiet halls of scholarship, a different kind of revolution was taking root. This transformation occurred in the most famous repository of knowledge the ancient world would ever know, the Library of Alexandria. Founded in Egypt under Greek rule, the library became a magnetic center for thinkers across the Mediterranean. And it was here that the millennia of Egyptian celestial observation met the Greek passion for geometric models and philosophical inquiry. The Greeks did not start from scratch. They inherited a priceless treasure, centuries upon centuries of meticulous Egyptian data. Generations of priests had recorded the movements of stars, the cycles of planets, and the rhythms of the sun, compiling an observational record that spanned longer than any living memory. This was not just a list of myths, it was a long-term date, a set of unparalleled depth. When the Greek astronomer Hipparchus came to Alexandria, he accessed this vast archive. It was this Egyptian data, this long history of watching the sky, that allowed him to make one of his greatest discoveries, the precession of the equinoxes. By comparing his own observations with the much older Egyptian records of star positions, he noticed a slow, gradual shift. the entire celestial sphere was slowly wobbling, causing the equinox points to drift backward through the zodiac over a cycle of about 26,000 years. He could only detect this incredibly slow motion because the Egyptian records gave him a baseline stretching back centuries. This foundational discovery of precession was a direct product of Egyptian patience meeting Greek analysis. This collaboration reached its zenith with Claudius Ptolemy, working in Alexandria centuries later. His great work, the Almagest, became the Bible of astronomy for over a millennium. In it, he synthesized everything he knew, creating a complex mathematical model to predict the motions of the planets, and the bedrock of his entire system was the observational date, painstakingly gathered by the Egyptians. Their star catalogs, their lists of planetary positions, their records of eclipses, all of it provided the raw material that Ptolemy's geometrical genius could shape into a predictive machine. The Greek astronomical revolution, often credited to these great minds, was in fact a joint endeavor. It was built upon a foundation laid stone by stone, observation by observation, by the Egyptian priests who first turned the sky into a science. The Library of Alexandria was not just a Greek institution, it was the vessel where two great intellectual traditions fused, proving that the legacy of the Egyptian stargazers did not fade. It simply learned a new language and changed the world. Long before the first pyramid cast its shadow, another civilization was already charting the heavens. Far to the west of the Nile, in what is today a brutal desert, lies the Nabta Playa stone circle. This ring of standing stones is not just old, it is ancient, dating back as far as 5,000 to 3,000 years before the Common Era. This was a time before pharaohs, before hieroglyphs, before Egypt was even Egypt. Yet here, in this now barren basin, a community of cattle herders arranged massive slabs of rock with clear and deliberate purpose. The circle itself is just one part of a larger complex of megaliths, including tumuli and calendar stones, all positioned with an eye toward the sky. Researchers studying the site have found that key sightlines between the stones point directly to the horizon where specific stars would have risen. The brightest star in our sky, Sirius, was one of these targets. Another was the three stars of Orion's belt. The alignments are too precise to be accidental. This was a functioning observatory, a place where the first light of these crucial stars could be marked and celebrated, likely to signal the coming of seasonal rains to this then green savanna. The implications are staggering. This means that the sophisticated astronomical practices we associate with the great dynasties of the Nile Valley, the tracking of Sirius and Orion, did not suddenly appear. They had deep, prehistoric roots, cultivated not by a centralized state with grand temples, but by a nomadic people who needed to read the sky to survive. The stone circle at Nabta Playa is a silent, powerful testament to a tradition of celestial observation that would eventually flow into the Nile, becoming the bedrock of a civilization that would build its identity upon the stars. The silent stones of Egypt tell many stories, and not all of them agree. This is the great frontier where established Egyptology and provocative alternative theories often meet, not with a handshake, but a standoff. On one side stands mainstream academia, a discipline built on a century of meticulous excavation, linguistic analysis of hieroglyphs, and the careful dating of artifacts. Its conclusions are built layer by layer, like an archaeological dig itself, prioritizing context above all. A potsherd is not just an object, it is a piece of a puzzle whose meaning comes from the soil it was found in, the tomb it was placed beside, and the texts that describe its use. This method is slow, painstaking, and often cautious, resistant to leaps of logic that cannot be supported by physical evidence. For these scholars, the lack of a single hieroglyph explicitly linking the Giza pyramids to Orion's belt is a deafening silence, a deal breaker for a theory that seems so visually perfect. Yet, from the other side, comes a powerful and compelling question. What if the evidence we seek was never written down? What if it was encoded in the very positions of the stones themselves? Alternative historians often approach the mystery from a different angle, one of pattern recognition, celestial alignment, and a willingness to read the monuments as a grand, symbolic text. They argue that an over-reliance on textual evidence can blind us to a civilization's nonverbal language. the language of sacred geometry and astronomical intent. The visceral pull of these ideas is undeniable. They connect the dots in a way that feels intuitive and grand, offering a vision of an ancient world far more sophisticated and globally connected than we ever imagined. So how do we navigate this divide? The key is not to choose a side and dismiss the other, but to become critical thinkers ourselves. When evaluating any claim, ask about its evidence. Is it based on a single alignment, or does it fit a repeated pattern across multiple sites? Does it respect the archaeological context, or does it require ignoring layers of other finds? A compelling idea should grow stronger when tested, not retreat into greater speculation. The true story of ancient Egypt is likely far more complex and wonderful than any single narrative can contain. It is a conversation across millennia, and sometimes the most profound truths are found not in the shouts of certainty, but in the quiet space between the questions. The silent stones no longer hold their secrets as tightly as they once did. We are now witnessing a second great age of Egyptian discovery, not with shovels and brushes, but with particle detectors and lasers. Modern technology is peeling back the layers of time, giving us a view of ancient genius that was once invisible to the naked eye. One of the most powerful new tools is LiDAR, a form of laser scanning. From an airplane or drone, it can map the ground's surface with incredible precision, even penetrating light vegetation to reveal what lies beneath. Archaeologists are using LiDAR to find buried pathways, lost settlements, and the faint outlines of immense ceremonial centers. These scans have revealed that certain temples and pyramids are part of much larger, carefully planned complexes, all oriented along celestial lines we are only just beginning to appreciate. It is as if we are being given a god's eye view of a celestial blueprint drawn on a continental scale. Meanwhile, inside the pyramids themselves, a quiet revolution is underway. The Scan Pyramids mission, an international scientific project, is using cosmic rays to see through stone. This technique, called muon tomography, relies on muons, subatomic particles that constantly rain down from the atmosphere. These particles can pass through solid rock, but denser materials absorb more of them. By placing sensitive muon detectors inside chambers like the Grand Gallery of the Great Pyramid, scientists can measure how many muons pass through the surrounding blocks. This creates a three-dimensional density map, revealing hidden voids or chambers without moving a single stone. It is a non-invasive X-ray on a monumental scale, and it has already identified several previously unknown spaces within the Great Pyramid, sparking a new wave of questions and theories about its internal structure. To understand what the ancient builders saw, we must also look up with their eyes. Astronomy software allows us to rewind the sky. By inputting precise geographical coordinates and using complex algorithms that account for the gradual wobble in the Earth's axis, known as precession, we can recreate the exact night sky over Giza or Thebes on any date in the past. This digital time machine proves that the alignments we suspect are not coincidences. We can watch Orion's belt crest the horizon exactly as the pyramids were completed, or see Sirius make its first pre-dawn appearance from the vantage point of a specific temple altar. This software transforms speculative alignments into testable, verifiable data, confirming that the shafts within the Great Pyramid did, in fact, point directly at specific stars 4,500 years ago. Even the smallest artifacts are now telling their own cosmic stories. Advanced chemical analysis of pottery, stone tools, and even the residues inside ceremonial vessels can reveal where materials originated. By tracing the unique chemical fingerprint of an obsidian blade or a lump of lapis lazuli, scientists can map ancient trade routes that brought these precious items across vast distances. This tells us that the knowledge required to build these astronomically aligned structures was not developed in isolation. Ideas, along with goods, traveled, suggesting a possible exchange of celestial knowledge between ancient cultures that we are only beginning to piece together. Each of these technological threads, from the cosmic to the microscopic, is weaving a new and far more complex picture of ancient Egyptian science, one that confirms their mastery of the heavens was not myth, but a measurable, engineered reality. The silent stones and star charts have spoken, revealing a truth far grander than myth alone. The ancient Egyptians were not merely stargazers lost in wonder. They were master engineers of time and space, using the cosmos as their ultimate blueprint. Their astronomy was a foundational science, the invisible engine of their entire civilization. They engineered a 365-day calendar from the reliable pulse of the star Sirius, a clock that dictated the rhythm of the Nile's flood and the survival of millions. They carved the night into precise hours using the predictable dance of decans stars, creating a 24-hour clock written in light. And with nothing more than a palm rib and a plumb line, they harnessed the circumpolar stars to align the Great Pyramid to true north with near-impossible accuracy, anchoring their most sacred monuments to the very axis of the world. This was a science of breathtaking ambition, where the sky was not a tapestry of distant gods, but a practical, predictable tool. It was a system that fused the celestial with the terrestrial, guiding the pharaoh's soul to the afterlife while simultaneously organizing the farmer's planting season here on Earth. Their legacy is a powerful reminder that human curiosity, when paired with meticulous observation, can unlock the secrets of the universe itself. So as you look up at the night sky, think of the Egyptians who saw a magnificent, ticking machine. We would love to hear which of their achievements amazes you the most. Was it the celestial calendar born from Sirius, the star shafts within the Great Pyramid, or the simple genius of the Merkit? Share your thoughts in the comments below, and subscribe to join us on our next journey into the world's greatest ancient mysteries.